For this problem, we were asked to find 4 different values and then put them into conic equations and find algebraically the intersection points between the two conics. So for this, I had x minus 5 squared over 40 squared plus y plus 15 squared over 20 squared equals 1. And then for the second one, I had x plus 20 squared over 5 squared minus y minus 15 squared over 20 squared equals 1. So then I chose to expand the quadratics on top and make them look like this, and then square these all the denominators as well. Now to continue, like what I'm trying to achieve, which you'll see later is elimination, I multiplied by the largest denominator in each conics, in each equation really. So I multiplied this one up here by 1600 and was left with nothing up here and then 4 right here. So I'll have to distribute the 4 to all of these. And then for this one, I multiplied by 400, got rid of this, and then was left with 16 times all of this up here. And then now I can compare the two. I can see, okay, it's probably going to be easier, like just for numbers wise, to get rid of the y squared. So I multiply by 4 to get rid of the y squared. And I'm left with 65x squared plus 2550x plus 25,625x plus 240y equals 3,200. Now what I want to do is that I want to solve for one of the variables, so I'm going to isolate y because it's the only like out of place term in the equation. So I move this over, so I subtract this from this, and then I move the 240y over to the right, and then divide this whole thing by negative 240, and I'm left with this up here for y. When simplifying, y equals negative 13x squared plus 510x plus 4,485 over 48. And now what I'm going to do, which is, a real fun time, I put this back into my first conic up here for y, and I expand into all this like gross, messy algebra until I'm left with, after doing all these calculations and then adding this up here to that, I'm left with a quartic, which is 169x to the fourth plus 13,260x to the third plus 358566x squared plus 383454x 540x plus 1326825 all equal to 0, which I know is a lot, but algebra sleeps for no one. So now with that, I can actually graph that quartic, and it will intersect the x-axis 4 times, and at those 4 intersections, it gives me the x values of all of my intersections for these two conics, which is like really cool, you know, like math, like super cool. So with those x values now in place, I wrote them down right here. You can see if you would like to take a look. You can find those x values, and then if your heart so desires, put them back into here, and then you could technically solve for the y values right here. And that would give you like the appropriate y values, and that would give you the points you need to find the intersections algebraically. And so the points are listed down here for all of the things, and those are the intersection points by finding them algebraically.